Here we will deal with the mean depth of rainfall over an area. So basically there are three methods to find out this. First one, arithmetic mean method. Second one, Thiessen polygon method, and the last one, Isohyetal method. Amongst the three, the most accurate one is Isohyetal method. We will deal it later. So first of all, we will deal with the first one, arithmetic mean method. You simply consider you have an area of, so this is your area, and you are getting rain over the whole of the area, and you have some rain gauges here like this, and almost uniformly distributed the rain gauges. So you have G1, G2, G3 up to Gn. You have number of rain gauges, Gn number of rain gauges. So in arithmetic mean method, you are doing the simply taking the average of the all of the depth recorded in this rain gauges, so that let P1, P2, P3 etc. up to Pn be the depth of rainfall in G1, G2, G3 up to Gn rain gauges. So in arithmetic mean method, you will get the average mean depth, that is P is equal to P1 plus P2 plus P3 up to Pn whole divided by n. That is also equal to sigma I is equal to 1 to n Pi divided by n. So the importance or the points to note here is that the result obtained by this method correct only if the rain gauges are uniformly distributed, as I said earlier, over the area, and the rainfall varies in regular manner. So if the rain gauges are uniformly distributed, this result will give you the more accurate result, or otherwise you have to go for the next method, that is the second one. This is the Thiessen polygon method. Thiessen polygon method. So in Thiessen polygon method, the same area we are considering, this is the area, and you have the rain gauges. Let's say there is a 4 rain gauges. It can have up to n number of rain gauges are there. So for the sake of the time, we will take four rain gauges. This is G1, G2, G3 and G4. Here in Thiessen polygon method, what the method do is it will join the adjacent gauges, rain gauges with a straight line like this, and all the rain gauges are connected. Okay, so you can see number of triangles are there. So this is the basic part, and in Thiessen polygon method the rain gauges are connected by dots or lines, and then you will have the number of triangles. And what here do is for each of the line we will draw a bisector. Bisector means it is dividing this line uh, at the midpoint. So here you can see this is the bisector. So this is the bisector. For G1, G4, this one is the bisector. For G1, G2, this is the bisector. It's a perpendicular bisector. Okay. So in the second case, for here also we will draw the bisector. Likewise, complete the bisector for all the lines. Like here we will complete this. So we have bisected all the triangles, and what we are doing or assuming is that for this area, the G1 or the precipitation in the rain gauge G1 will represent the average rainfall over this green shaded area. Okay. Likewise, the precipitation in G4 like this, G4. Precipitation G4 will take care of the uh, the area of that violet shaded area, and likewise G3 and G4 will take care of the other two areas also. So in this method, what the final answer is, let P1, P2, P3 and P4 corresponding to G1, G2, G3 and G4. So that P1 is serving the area of A1, P2 like area of A2, P3 area of A3, and that P4 serving the area of G4. So that the precipitation or the average weighted precipitation is equal to P1 into A1. A1 is this green shaded area. P1 into A1 plus P2 into A2 plus P3 into A3 plus up to Pn into An if you have n number of rain gauges and area divided by total area. So While looking at this equation, you can see that the precipitation is the weighted average of the whole precipitation. So the basic difference between the arithmetic mean and Thiessen polygon method is that if your area and you have the area is like this and your rain gauges are mainly concentrated in one area and this much rain gauges are here and only two rain gauges are here, and if you do the problem in arithmetic mean you will get the answer which is varying varying drastically from the actual average rainfall. But if you do it in the weighted average method or Thiessen polygon method, you will get this two rain gauges will serve the more area and you can get the more accurate result for undistributed rainfall undistributed rain gauges situated. Okay, so this method is more accurate than the arithmetic mean method. So the next one is the Isohyetal method. So in Isohyetal, this is the most accurate method we have so far discussed. So in this method, you are taking the same area, okay, and you have the rain gauges here and there. You have the rain gauges, and what you are doing is you are taking the dimensions or the rainfalls in this rain gauges G1, G2 up to Gn. You are taking the dimensions of the rainfall depth in these rain gauges and you are taking or you are assuming that the variation from the rainfall value from G1 to G2 is linear and you can interpolate. Let's say that here this is 150 centimeter and here it is 200 centimeter like this. Here 150 centimeter and here it is 200 centimeter, and you have to locate the 175 centimeter rainfall area. So it is at the midpoint of this two rain gauges because of we are assuming a linear variation between the G1 and D2. Okay, so you can locate 200 or 175 centimeter rainfall at the midpoint. Okay, so we are assuming a linear interpolation between G1 and G2. So likewise, from all the values of the precipitation, you can locate the points of the same rainfall depth. Locate the points of the same rainfall depth. Let's say it is here also it is 175. Here also it is 175, and you are drawing or you are connecting this same rainfall depth points. You are connecting this same rainfall depth points. Here it is. This line is called Isohyetal. This is called Isohyetal of 175 centimeter. Likewise, you have here, while interpolating you will get it is, or you have 300 centimeter isohyetal. So what is an isohyetal? Isohyets are the imaginary line connecting the equal points of rainfall depths. Okay, So you are drawing the isohyets, and to calculate the average rainfall depth over the entire area, you are dividing this isohyets. You are calculating, or you are dividing this area into number of isohyets points, and the average rainfall depth P is equal to sigma of area between two adjacent isohyets into mean of two isohyet values. Mean of two isohyets values all divided by area. So what it means? The area between two adjacent isohyets. What is that? The area between two adjacent isohyets. Let's take this is the two adjacent isohyets, and this is the area between two adjacent isohyets. This is the area between two adjacent isohyets. Okay. So likewise here also one area will be there, and here one area, and here is also another area. Okay, so this is the area between two adjacent isohyets, and the mean of two isohyets values, and the mean of two isohyets. So let's say this is 300 centimeter, and let's say this is 250 centimeter isohyets. So what will be the mean? We are assuming a linear interpolation between the two, and the mean value will be 275. Okay, so the mean value of two isohyets that has to be taken. So that's likewise this is for this area, plus again for this area also, and the area and the isohyets mean value, that is between this one and this one. So you can calculate the precipitation rainfall depth in the area by Isohyetal method. And the points to remember is that the Isohyetal method is more accurate and than the Thiessen polygon method, and Thiessen polygon method is more accurate than the arithmetic mean method. Okay.